Okay, today we're going to learn properties of trapezoids. And I've given you 3 different pictures here of what a trapezoid looks like. And maybe you'll be able to tell what they all have in common and what's different about them. But the definition of a trapezoid is a quadrilateral. And you remember what the word quadrilateral means? It means it has 4 sides. Quad means 4. So these are all 4-sided shapes with only one pair of parallel sides. So you can probably identify between these 3 pictures that I have down here for you which are the parallel sides, and we'll label them with arrows. Those 2 sides are parallel. These 2 are definitely not. These 2 sides are parallel, and these 2 sides are parallel. So they all have at least only one pair of parallel sides. And there is some important vocabulary that goes along with trapezoids as well. Those parallel sides, all those sides that we labeled with little arrow marks, those are called the bases. Those are the parallel sides. And there's always 2 of them in a trapezoid because there's always 2 sides that are parallel. The legs, well, what do you think the legs are going to be? They're the other 2 sides. They're not parallel sides. Okay, and then the base angles, there are 2 pairs of them, and they are along the parallel lines, or the angles formed on the bases. So I'll use my highlighter and I'll show you. So here's a pair of base angles because they're formed along this base. Here's another pair of base angles, those 2, because they're formed along this base. So we can do that for all 3 of them, this angle and this one. Those are formed along this base, and this angle and this one are formed along that base. And we got 2 left. I'll use different colors this time. This angle and this one are base angles. Those are formed along that base. This angle and this one are formed by this base. So that's what we mean by base angles, and when we talk about what an isosceles trapezoid is, the base angles will be pretty important. So let me erase all my highlighting here. So we're going to talk about what the differences between these 3 trapezoids up here are before we move on to the isosceles trapezoid. So maybe you can tell. This trapezoid is just a normal trapezoid. There's nothing special about it, and the reason I know that is because this side and this one are different lengths. Okay, so that's just a regular trapezoid, no big deal, no problem. This trapezoid here is going to be called a right trapezoid because there's a right angle. I didn't draw it in there originally, but that's why this is going to be called a right trapezoid, because we have right angles here. This side is perpendicular to the 2 bases. And then this one, I didn't draw in these either, but these 2 sides are equal, and it's just like a triangle that has 2 equal sides is called isosceles. Well, it's the same thing for a trapezoid. This is called an isosceles trapezoid because it has 2 equal sides. Okay, so that's going to take us to our definition down here at the bottom. Now we're going to talk only about that 3rd option, that isosceles trapezoid. An isosceles trapezoid is a trapezoid, duh, right, with 2 congruent sides. Or you can say the legs are congruent. Okay, so that means that this side equals this one. And there are a few properties of an isosceles trapezoid. First of all, it has 1 pair of parallel sides. That's what makes it a trapezoid. And what makes it isosceles? It has the legs congruent. That's what makes it isosceles. So we took care of trapezoid and we took care of isosceles. There's 2 other cool things about this. One of them is that the diagonals are equal. So if we draw the diagonals in, they're the same length. Diagonals congruent, or equal. You know, congruent is just a fancy word for equal. And let me erase those diagonals real quick. The last thing is that the base angles are congruent. Just like in an isosceles triangle, you might remember that property. It's the same thing for an isosceles trapezoid. The base angles are congruent, and just keep in mind that there's two pairs of them. In a triangle, there's only one, but we have two bases in a trapezoid, therefore we have two pairs of base angles. That means that this angle equals this one, and the top two angles equal each other. So remember what those base angles are. We talked about those up here when we were using the highlighters. The base angles. In an isosceles trapezoid, the base angles are always congruent. Just like in an isosceles triangle, except in a trapezoid you have two pairs of them because there are two bases. Okay, I do have a couple practice problems down here at the bottom. And in the directions it says both images are isosceles trapezoids. So what that means is our sides are equal here, which means our base angles are equal, which means this is 68. Okay, and up here, there's another property about trapezoids, and this isn't just isosceles trapezoids, this is all trapezoids, and that's kind of like the parallelogram properties, is that the consecutive angles, the angles formed by the C's on the parallel sides, are sup. And what does sup mean? That means they add up to 180 degrees. So you can figure out what this top angle is up here. Because we know the bottom one is 68, so we're just going to subtract that from 180, and we're going to get 112 degrees. Because it has to be sup with the 68. And that means that over here, since they're congruent, these are both 112 degrees. So just remember those C angles, the angles that form the C's when you draw the base and the leg, the two bases connecting by the leg. Those C's that are formed are always consecutive angles, and they're always supplementary. Okay, so down here we have another isosceles trapezoid, and you can tell which side is your parallel one. Sometimes the textbook or the worksheets will flip the trapezoid upside down and try and confuse you. You can still tell which side is parallel and which sides are congruent. And that means that this angle, these two base angles, have to be equal. So they're both 103. Excuse me. And then when we find our C angles, our consecutive angles, those have to be sup. So when I do 180 minus 103, I get 77 for this angle. And since that's a base angle, that means that this one is also equal. So the moral of the story with isosceles trapezoids is that the base angles are always equal. So if you have one angle, you can always find the other base angle. Like the 68, we found this 68 right away. And then how do you get the other two? Well, they're sup. They're supplementary, meaning they add up to 180. So it's some very simple math that you need to do. Today's lesson is on properties of quadrilaterals, and most specifically, we're going to be learning about three particular quadrilaterals: the rhombus, the rectangle, and the square. And so what you're going to notice about the rhombus, rectangle, and square is that they're all parallelograms. Therefore, the first 5 properties are all the properties of parallelograms. They just have a few things that are a little bit more specific. So we're going to start with the rhombus, and the definition of a rhombus is a parallelogram, because they're all parallelograms. But this one has 4 congruent sides. So I'm going to go down to my rhombus figure that I have down here, and since it is a parallelogram with 4 congruent sides, what I'm going to do is mark all 4 of the sides with one little tick mark, because that tells me that all 4 of the sides are congruent. And the hard part is probably trying to remember all 5 of the properties of parallelograms, and then doing a little bit more specific. There's 3 additional ones that are specific to a rhombus. So remember, these 5 are all parallelogram properties. So what are those properties? Opposite sides are parallel. Opposite sides are congruent. We have opposite angles that are congruent as well. We have, let's see, diagonals that bisect each other. So they cut each other in half. And the last one is the consecutive angles. angles, those all add up to 180 degrees. For example, this one and this one, they are sup, which means they add up to 180 degrees. So that means consecutive means in a row. Any two angles in a row add up to 180 degrees. So what's specific about the rhombus? Well, the definition is it has all four sides congruent. Okay, and there's two other things. One thing that's pretty cool is that the diagonals, when you draw them in, and we will in just a second, they're perpendicular. They form right angles. So let's draw those in. Since we already labeled all four sides congruent, I'm going to draw in those diagonals, and if you're pretty good at drawing straight lines, they should look to be pretty much right angles. They should look like they're perpendicular. And the last thing is that the diagonals bisect the angles. So we'll fill this in. And what does that mean? That means that this angle is equal to this one. And that means that this angle is equal to this one. So that angle is being cut in half. This angle equals this one. This angle equals this one. So those are the three new properties about a rhombus. And just keep in mind that the first five are the properties of a parallelogram. So now we're going to move down to the rectangle, and the rectangle is a shape that most of us probably recognize, and what makes a rectangle special is that it is another parallelogram, and it has four right angles. So I'm going to label those four right angles on my rectangle before we move any farther. So make sure you put all your boxes in the angles for the rectangle. And just like the rhombus, the first five properties are the exact same as what we just did for the rhombus, because a rectangle is a parallelogram as well. So again, we have opposite sides parallel, opposite sides congruent, opposite angles congruent. What else do we have? Diagonals bisect each other. So they cut each other in half. That's always true for all parallelograms. And what's the last one? The consecutive angles are sup, meaning any two angles in a row. So these top two add up to 180, these two on the right add up to 180, the bottom two add up to 180, and these two on the left add up to 180. And part of the rectangle definition was that all four angles are right, so I'm going to put all angles are right angles, or you can write 90 degrees if you prefer to write that. And the other thing is about the diagonals in a rectangle. The diagonals are actually equal in a rectangle. So I'm going to use diagonals congruent. So we already labeled our 90-degree angles. I'm going to try, it's a little bit harder on a rectangle, I'm going to try and draw in the diagonals. And the diagonals are congruent. There we go. Okay, so maybe you want to make a note to yourself up here since we have some extra space. Diagonals are the same length. Okay, and the last shape we're going to talk about for today is the square, and that's on the back side of your worksheet. And a square is basically a rectangle and a rhombus put together. It has every single property of both of those. So again, it's another parallelogram, and it has both parts, the rhombus and the rectangle, with four congruent sides and four congruent angles. So basically it is a rhombus and a rectangle. So what we're going to do is we're going to label all four sides congruent. 1, 2, 3, 4, just like we did for the rhombus. And we're going to do the same thing we did for the rectangle. We labeled all the angles as 90 degrees, so we put our boxes in all four of the angles. And the properties, that's just a really long list that we're going to have to fill in. So just like we did earlier, the first 5 properties are the 5 properties of all parallelograms. And we should be able to write all 5 of them in our sleep by the time we're done with this worksheet. Opposite sides parallel, opposite sides congruent, opposite angles congruent. Oops, not opposite. I get writing too fast. The diagonals bisect each other, and the consecutive angles are suck. Those are the first 5 that we wrote for the rhombus and for the rectangle. And then we're going to take the other properties of the rhombus and the rectangle and list them down here. So remember the rhombus, it had all 4 sides congruent. So all sides congruent. The rectangle had all angles congruent. We have the diagonals congruent. We have the diagonals bisecting the angles, just like it did in the rhombus. And let's see, what are we missing? Diagonals are perpendicular. Remember, they form right angles. So I'm going to draw all those things in. Hopefully I'm going to draw in the diagonals like this. And I'm going to label my right angle. My diagonals are congruent. They still bisect the angle, so it cuts each 90-degree angle into 45. That's kind of cool to know. Since they're all 90 degrees, that means it cuts them all in half. All 4 angles equal, all 4 sides are equal, diagonals are perp, they bisect each other, and they're congruent. So a big list, and the order doesn't matter for the list. Sometimes if you have them memorized, you list them in the same order every time, but since it's just a list of all the properties, it doesn't really matter which order they go in. So now you have a list of all the properties of a rhombus, rectangle, and a square, so that you can match them up and know some of the cool things about all these different types of quadrilaterals.